Hi, my name is Evie Barnett.
Hi guys, my name is Thomas Beck.
Hi all, my name is Kennedy Young. Today we will be educating you guys on some of the properties of an orange. You may wonder how this can connect to your daily life. Say you're going through the lunch line and they have two options of oranges, peeled oranges or orange wedges like cut with the peel still on. Some of the properties that we're going to teach you how to measure and get results for are the modulus of elasticity, the moisture content, and the sphericity. These can connect to make a decision on what orange you want more. For example, the moisture content in an orange may relate to how juicy it is. Therefore, if you don't like as much juice in your oranges, you may want a less moisture content. We'll teach you how to derive this and help make a decision. The second is the sphericity. If you have orange wedges with the peel still on, the sphericity of the orange will probably be a little bit bigger than with the peel off, therefore may take up more space on your tray, and you may not get as many. And the third is the modulus of elasticity. This tells how hard or soft a piece of fruit or something is and could help you decide if the fruit is ripe enough or if it's too ripe and not good to eat. I hope that measuring these properties can help you make a decision.
Hi guys, I want to talk to you today about the differences between a biological and non-biological material, and I want to talk to you about the material that we will be using for our experiment. So the difference between a biological and non-biological material is based upon whether it will classify with the 6 biological material properties, which are that they have to be naturally derived, they have to be self-assembled, they have to have multi-purpose intentions, they have to have high variability, they have to be heterogeneous, and they have to be moisture dependent. So let's consider that with our material that we're going to be testing, which is an orange. So an orange is naturally derived because obviously it comes from natural materials. It's mostly carbohydrates, water. That's what it's mainly comprised of. It's self-assembled. It grows on its own. It didn't require a man-made machine to make it or anything. It has multi-purpose intentions. It serves as a way to attract animals to spread the seeds, but it also protects the seeds. And for us humans, we just grow them to eat them. They have high variability. No orange is the same. They're heterogeneous. When you look at an orange, it's composed of the rind. It has the flesh in the middle protected by a skin. And lastly, it's moisture dependent because the oranges have water and they require that water to live. That's all, guys. Thanks.
The first property we will talk about when investigating the orange is sphericity. Sphericity is the shape of an object relative to that of a sphere with the same volume, and sphericity is a unitless property. In lab, sphericity is measured very similarly to how we are going to measure sphericity today. However, the instruments in lab may be more precise than what we will be using at home. Sphericity can be found by measuring the major, intermediate, and minor diameters of the orange, and then plugging them into the equations found on the procedure document. The second property we will be looking at in this experiment is moisture content. Moisture content can be broken up into 2 categories: moisture content dry basis and moisture content wet basis. Moisture content dry basis is the ratio of the mass of the water in a product to the mass of the dry matter in the same product. Moisture content wet basis, on the other hand, is the ratio of the mass of the water in an object to the total mass of that same object. Moisture content is then measured as a percent. In the labs at Chase, moisture content would be measured by taking the entire mass of an object beforehand and then placing the object in an oven for several days to get rid of all the moisture, which leaves just the dry mass of the object to be recorded. Since placing the orange in the oven for several days is an unlikely option, in order to get rid of all the moisture within the orange, for this procedure, we will squeeze all the juice out of it and take the mass of the orange without the juice to determine roughly its dry mass. And then following the equations in the procedure, you will be able to calculate moisture content wet basis. The final property we will be looking at is a mechanical property called modulus of elasticity. Modulus of elasticity is the ratio of the stress divided by strain experienced by a material and is typically recorded in units of megapascals. In lab, modulus of elasticity is typically measured using a universal testing machine which can very accurately record the stress and strain experienced by an object. However, we do not have access to these kinds of machines at home, so we will be measuring this property using a 5-pound force and then recording the change in height experienced when the orange is under that much force. Using these numbers, you will plug these into the equations found on the procedures document and be able to calculate modulus of elasticity. Engineering properties are unique because they are unique responses to stimuli that are both intrinsic to the material tested and are quantifiable. Due to the way these properties are measured and found, they can be compared between objects and can stand alone.